Welcome back to Advent of Code 2017, day 13. Packet scanners. You need to cross a vast firewall. The firewall consists of several layers, each with a security scanner that moves back and forth across the layer. To succeed, you must not be detected by a scanner. By studying the firewall briefly, you're able to record in your puzzle input the depth of each layer and the range of the scanning area for the scanner within it, written as depth range. Each layer has a thickness of exactly 1. A layer at depth 0 begins immediately inside the firewall. A layer at depth 1 would start immediately after that. For example, suppose you've recorded the following: 03, 1, 2, 4, 4, 6, 4. This means that there's a layer immediately inside the firewall with range 3, a second layer immediately after that with range 2, a third layer which begins at depth 4 with range 4, and the fourth layer which begins at depth 6, also with range 4. Visually, might look like this. 0 has 3, 1 has 2, yeah, and then 4 has 4, and 6 has 4. Within each layer, a security scanner moves back and forth within its range. Each security scanner starts at the top and moves down until it reaches the bottom, then it moves up until it reaches the top and repeats. So we go here is the scanner, then it's here. Then it moves down here, and then here it moves back up again. And here it's at the bottom. Your plan is to hitch a ride on a packet about to move through the firewall. The packet will travel along the top of each layer, and it moves at 1 layer per picosecond. Each picosecond the packet moves 1 layer forward. Its first move takes it into layer 0, and then the scanner moves 1 step. Scanners move 1 step. If there is a scanner at the top of the layer, as your packet enters it, you are caught. If a scanner moves into the top of its layer while you are there, you are not caught. It doesn't have time to notice you before you leave. It moves onto the layer while you are there. Doesn't matter, but if I move into the scanner, it matters. If you were to do this in the configuration above, marking your current position with parentheses, look like this. So we are here. We kind of move onto this field, and then the scanners move. And then we move, and then the scanners move. Okay. Just wondering if, okay, picosecond 4. Okay, in 3 it's here. And then it moves up again, so it moves up again slowly. Okay. In this situation, you're caught in layers 0 and 6 because your packet entered the layer with its scanner was at the top when you entered it. You are not caught in layer 1 since your scanner moved into the top of layer once you were already there. Yeah, that's fine. The severity of getting caught on a layer is equal to its depth multiplied by its range. So first layer, ignore a layer in which you do not get caught. The severity of the whole trip is the sum of the values. In the example above, the trip severity is 0 times 3 plus 6 times 4. Given the details of the firewall, you're recorded if you leave immediately. If you leave immediately, what is the severity of your whole trip? So this is the full input. Let's start with the example. We have the lines now. So we go and we have a, what was it? Depth and range. Scanner. We can like split the line like this. Oh yeah, depth. Range. Then we know these scanners, so they have, let's see if it's correct, depth and then range, yeah. And depth means this number at the top. Okay, so I will kind of go C is 0 while C is smaller than last, let's say depth, or maybe I reach the last depth. I will check if I'm caught or not. So I go find the scanner, at my depth. Hmm. Let's just do first all null. There's a scanner, I need to check. And then anyway, we go increase C. Now I just need to check, am I, is a scanner on 0? Hmm. If I can get the scanner's positions, can be no, let's just add it here in the file. And they all start at position 0, I guess. Then I just need to check. So what happens first? I move in picosecond 0, right? And then I check. So I always get caught at the beginning. Then I update the scanners. And then I update myself in picosecond 1. Okay, so I find the scanner 0 and then the scanner 0 position if it's 0. If the position is 0, then I'm caught. And I have to say chord equals maybe I can just do result is 0, and then the result gets increased by scanner dot depth times scanner dot range. Is that it? The severity. Okay. Now I just have to move the scanner. So first I check if I'm caught. Then I move the scanner. And then I move myself. Scanners dot map. Scanners equals scanners dot map. Scanner, well, it dot copy position equals position plus +1, but also sometimes sometimes -1. Yeah, like if position is greater than I feel like it's like if it's it dot range. What is the range again of depth? Range and then depth is this, right? Depth is 3. So if the position is depth -1, I have to kind of like decrease it. I need another thing, I think. Moving up, Boolean true. False. Else? Okay. We also have in more cases. If it dot pause, well, if it is moving up, +1 until I reach depth. If it's not moving up, I'm moving down. But if I reached 0 again, should move up again. Position equals. Yeah, okay. Something like this. Let's do else here. Or maybe let's just do else error. Another case. It. Something like this. Is that already it? Let's check what happens. 0. Weird. Okay, my scanners. Okay, my scanners like this. Then I go to depth 1. Then I have null, null, null. Then I'm at depth 4. Maybe I can like check the first scanner, see how it evolves. So we go. These are just all the scanners. And then we go to position 1, then we go to 2, then we go to 3, then we go to 4. Oh. Check range. Is that it? Yeah, depth and then range. Okay, yeah, I have to check range here. Okay, this is the example. Then I can do the real one. And get 2688. And that's correct. And then now you need to pass through the firewall without being caught. Easier said than done. You can control the speed of the packet. You can delay it any number of picoseconds. Okay, so we just let the scanners run a few times. What is the fewest number of picoseconds that you need to delay the packet to pass through the firewall without being caught? Like you're always caught in the first one, right? Or not? I know you're not, because the scanner is then going away. Okay, we have to scanners. Okay, let's say this is a function. Runs scanner. I don't know. And I should return the result. Something doesn't work. Why does it change that code? Anyhow. Okay. Then we can check if this still works. Yeah. Okay, then I have to check. What's the first one? 0, 4. Maybe I should just list int. And then I add this number there. Return that. Okay, and then I get some numbers, right? Yeah. Now I can check if res is empty. Then we're done. Otherwise, we just loop. And we have to change the scanners first. We have the code to update the scanner, right? This one. Bump scanners. Just bump them one further. I don't know why it always changes the code. Pico delay is 0. And we increase it. And then we just say pico delay. Okay, this prints all my things first, and then I'm running through this, I guess. Interesting, that's so... Can't be that far away, can it? Let's check the example again. This one. 10. That's correct. Weird. Oh, we already checked the first million, so I can run the next million. Wonder if I can make it faster somehow. I'll probably jump further than +1. So I can jump. I wonder what can tell us here that it will be 10. Ah, it stopped. Let's try that. Interesting. We know that this is smaller than this. That's interesting. Mm, um, that's odd. Wonder if I'm correct in my delay stuff. Would I also need to change something about the game? Hmm. Bump scanners. What does it do exactly? Takes each scanner, moves it. Oh, wait. I know I do increase by one and then run it. Hmm. Some number I missed? No. I'm dummy. If I do delay like that, then I can't. Then everything's offset wrong. I have to start at 0 and just let it run. Because otherwise my offset is not matching my Pico delay. Because I would need to bump the scanners 1 million times anyway. Okay, let's just start at 0. And then I do 1. And I bump the scanners once, that's fine. And then I run it. Okay. All right, so without the mistake from accidentally offsetting, we get this. And that's correct. So let's go through the solution. Part 1, we build these scanners, have a depth and range, and have a starting position. They all start at 0, and then they start moving up. They all start moving up. Once they reach the end, like this one here in picosecond 1, they move back down. So then they move back down, and then once they reach the start, they move back up again. So the first thing we make is a bump scanners functionality that takes the scanners and updates them by one step. If it reaches the end, we update. If it has reached the end, we update -1, and we say we're moving up is false. If it has reached the beginning, for example, at the beginning, it's at the beginning, we go +1 and move up true. If we're just moving up and we haven't reached any of the ends, we go +1, and if we're just moving down, haven't reached any of the ends, we go -1. So we can update the scanners for one step. Then for each pico delay, so we start at 0. For part 1, we can just run this once, which is the run scanners, where we started a counter that goes from 0 to the end of the list, the last one in the list, this one's depth. So it starts at 0 and it tries to add elements to this list of results every time I'm caught. How do I know I'm caught? Is if there's a current scanner at the depth where I'm at, for example 0, I get the first one. If it exists and the position of that scanner right now is at 0, I'm caught. Then I can add the result to the list, which is calculated as scanner.depth times scanner.range. Then, after I'm caught or not, I do this bump scanner, update all the scanners, and I update my counter to move on one depth further down the list. So I move from 0 to 1, for example. Then I do that until the end, until I reach the end of the list of scanners, and then I return the list of my results. So part 1, we're done. We just get the result, which is how often we're caught and how severe the caught catching was. This is run scanners sum, I guess, is the result. So if I would return here, I get the result 2688. That's part 1. Oops. Part 2, we do the same thing, but first we delay our entry by 1 picosecond or whatever. And then we do the same. We update all the scanners and we run the scanners. And then we check if the result is empty, then we're done. But it's not. So we continue with this loop. Then we increase the pico delay again, update the scanners one further. And then we run through the scanners again and check how often we're caught. If we're not caught, we're done. If we are caught, we're not done yet. Then we just do that until we're caught, and then we know how many pico delays we have to wait until we're caught. I think there's some optimization to do because we always know that at what points these different depths hit the start, so we can kind of skip a bit faster. So my code is not ideal, but it ran fast enough, so I'm happy with it. And that's the result for day 13. So enjoy the rest of your day.